Hello YouTube, I wanted to show how I make my OLED clocks, and the customer asked me if I can do it, and I gladly will show you. So it all starts up with a bare PCB that I get manufactured, of course. I cannot do it myself yet. I wish I could. Anyhow, this is how it looks like with all the parts attached, in this case for the clock. And as you see, I use the real quartz with the two 22p caps, and it have the charging circuit here. The LiPo is not attached yet. It has a micro USB on-off switch, the navigation switch that you can adjust the time and alarm and whatnot. It has 4 LEDs in the corners. And well, this is the PCB when it's bare. This is how it looks like with the battery attached, and I check it for if it's charging or not. The charging LED is in the back, and this is how it looks like in the back. So this is before attaching the other parts. What gets attached to this are the female pin headers, top and bottom, and the RTC module that I use with the clock is this one, and it starts out like this. I desolder the female pin header. Actually, I cut it off and take the pin out. Then it looks like this with the holes cleaned up like that, and then attach the male pin headers to it. I could, of course, on the clock itself, just solder the male headers here and attach the RTC module like this, like I did before. But you see the difference? It will stick out 3 to 4 millimeters more. So, come on, focus. So that's why I go through all the trouble with the RTC module, so it sits flush. Okay, and I also attach a piece of tape down here so it won't get any short circuits. There's actually nothing in here behind. Hold on, which way is it? Oh, there is actually, yes, that's why I do it, see? So you have the pins from the switch, from the navigation switch, so it won't happen anything, any shorts or anything else. I attach a piece of tape that goes in between the battery and the PCB, and then you get the watch. This is the LiPo I'm using. It has 180 milliamps. Sometimes it says 190 milliamps. It varies. And this is the piezo buzzer I'm using. This is the smaller one, 5 by 9 millimeter. The regular ones are 12 by 15 millimeters. So this is it, and this are the OLED displays that I'm using. On these I sand off the edges because they're rough most of the time, so they are smooth. And then I take out the plastic part of the pin header that's normally on there and shorten the pins. So if I plug it in, it saves me again 2-3 millimeters in depth. And the battery gets glued down with this M3 double-sided scotch tape. Just here, as you can see, I'm using the good stuff from Germany. This will give me quite a few more clocks to finish. Anyhow, and this is a clock. This is the dual color display, yellow on the top, blue on the bottom. They also come in white and blue. I won't go through the details because I did that already in another video. So here I just wanted to show you how it looks, and the display gets screwed down with the M2 screws. hex screws, and the hole here is 1.6 millimeters, which is the standard for threading. So the screws just thread into the PCB and hold it securely in place. So since it's like a modular, if anything breaks, it can be easily replaced, like the display or the LiPo battery, which has a limited life cycle, as you might know. And on the electronics, I didn't have a failure yet. Of course, I check them before I send them out. Obviously, I check the alarm, I check the beeper, and if everything is okay, it goes out to the customer, including a picture on his box, so he can see that his watch is working when I send it out. Anyhow, this is it. So these are the steps I go through to make my OLED clock. As you might think, it does take quite some time. Before I used to hand solder all these parts. Now I can use my lovely high-tech reflow oven, so that's a big plus. Anyhow, this is it for today. Just a small how I do things. Thanks for watching and take care, everybody.